Assalamu alaikum. Today we are doing the past paper questions of differentiation for the P3 course. Okay, the first question is the parametric equation of a curve R x equals to 1 plus ln t minus 2 and y equals to t plus 9 upon t for t is greater than 2. Show that dy by dx equals to this. Okay, so first of all we are going to find out dx upon dt. Okay, differentiation of 1 is 0. Differentiation of ln is whatever is with ln, you write it in the denominator. Okay, so I'm writing t minus 2 in the denominator, and then I'm going to differentiate t minus 2 and write it up in the numerator. Okay, so now I'm finding out dy by dt. So we know y equals to t plus 9 t minus 1. dy by dt is going to be 1 minus 9 t to the power minus 2. Okay, this can be written as 1 minus 9 upon t square. Okay, dy by dx is going to be dy upon dt divided by dx upon dt. Okay, dy upon dt is 1 minus 9 upon t square divided by dx upon dt, which is 1 upon t minus 2. Okay, let's take out the LCM. Multiplied by t minus 2 upon 1. This will become t square minus 9 into t minus 2 upon t square. This is what we had to prove in the first part. Okay. In the second part, they are saying find the coordinates of the only point on the curve at which the gradient is equal to 0. Okay, so you have to make dy by dx equals to 0. So yeah, I'm writing it down here. Make dy by dx equals to 0. Okay, so 0 equals to t square minus 9 into t minus 2 upon t square. T square minus 9 into t minus 2 equals to 0. Okay, from here you're getting three values which factorize this t minus 3, t plus 3 and t minus 2. If you make each bracket equals to 0, one answer is 3, one answer is a negative 3, which you have to reject because time cannot be negative, and one answer is 2. Since we know that t is greater than 2, that means you're going to just accept this value. Okay. Find the coordinates of the only point on the curve at which the gradient is equal to 0. So when t equals to 0, we need to find out what was the value of x and what was the value of y. That's what we are supposed to find out right now. Okay. So I'm writing when t equals to 3, x equals to 1 plus ln t minus 2. So 1 plus ln t minus 1 is t is 3, 3 minus 2 is a 1, and ln 1 is a 0. So it's 1, x is 1. And y equals to 3 plus 9 upon 3. So 3 plus 3, which is a 6. So the coordinates are 1, 6. This is the answer. Okay, moving on to question number 2. It says find the value of dy by dx when x equals to 4 in each of the following cases. Okay, here you have to apply product law because there are two functions being multiplied. One is x and the other one is ln x minus 3. Okay, so if I use y equals to uv, I know y equals to uv dash plus vu dash. Okay, u is x, so u dash is going to be 1. V is ln x minus 3, so v dash is going to be differentiate x minus 3 and write it up in the numerator. Okay, let's apply the formula. Dy by dx is going to be u v dash plus v u dash. Okay, so the answer is x upon x minus 3 plus ln x minus 3. Now you have to substitute the value of x as 4 into this, substituting x equals to 4. So it's 4 upon 4 minus 3 is 1 plus ln 4 minus 3 is 1. So 4 plus ln 1 is a 0. The answer is 4 for this part. Okay, for the second part, it says y equals to x minus 1 upon x plus 1. Here you have to apply the product law. So we know that if y equals to u upon v, dy by dx is going to be v u dash minus u v dash upon v square. Okay, in this question we know u is x minus 1 and u dash is going to be 1. v is x plus 1 and v dash is going to be 1. Okay. So dy by dx equals to x plus 1 into u dash, which is 1, minus u is x minus 1 and v dash is 1 upon v square, which is 1, x plus 1 the whole square. Okay, let's simplify this. X plus 1 minus x plus 1 upon x plus 1 the whole square. This will cancel out, leaving 2 upon x plus 1 the whole square. Now I'm going to substitute x equals to 4 in this. So it's going to be 2 upon 4 plus 1 is 5 square, which is 2 upon 25. So dy by dx is equals to 2 upon 25 in this case. Okay. Moving on to question number 3. It says the parametric equation of a curve R x equals to e to the power 3 at 8 and y equals to t square e to the power t plus 3. Show that dy by dx equals to this. Okay. So once again parametric equation. So x equals to e to the power 3t. So dx upon dt is going to be e to the power 3t, and then you differentiate the power and write it, multiply it with this. Okay, y we know is t square e to the power t plus 3. Now here you have to apply product law because there are two products being multiplied by each other. So I'm going to apply the product law. Dy by dx equals to u v dash plus v u dash plus the differentiation of 3 is going to be 0 because it's a constant. Okay, now since we have if you want you can take out e to the power t as common in this. So let's do that. If I take out e to the power t as common, I'll be left with t square plus 2t here. Okay, so we have to find out dy by dx here. So dy this was dy by dt. Okay, dy by dx is going to be dy by dt divided by dx by dt, or you can even write it by multiplied by dt upon dx. Okay, so actually you're supposed to multiply them. So dy by dt is e to the power t square plus 2t multiplied by the reciprocal of dx upon dt, which is 1 upon 3e 3t. The answer is going to be, okay, if I cancel out this e to the power t with 1 e to the power t here, I'll be left with e to the power 2t in the denominator. So t common, t square plus t plus 2. If I take out t as common from here, t plus 2 remains inside the bracket. Okay, and 3 e to the power 2t remains down in the denominator. This is what we had to prove in the first part of the question. In the second part of the question, it says show that the tangent to the curve at the point 1 comma 3 is parallel to the x-axis. Okay, let's find out the tangent to the gradient of the tangent. Finding gradient of the tangent at 1 comma 3. Okay. Okay, we know the value of x and the value of y. Let's plug it into this and get the value of t first, and then plug in t into this equation and dy by dx. Okay, let's finding out x, finding t when x equals to 1. Okay, I'm taking the first equation, x equals to e to the power. So x is 1. If you want to remove e from one side, you put ln on the other side, or you put ln on both the sides if you want to. Ln e to the power 3t. This will become 3t equals to 0 and t equals to 0 because ln 1 is 0. Okay, or if you wanted, you could have, in order to remove e from one side, you could have introduced ln on the side. Ln 1 equals to 3t. Okay, and then 1 is a 0, so 3t equals to 0, t equals to 0 aa gaya. Okay, even if you plug in the value of y as 3, which is given to you here, y equals to 3 into y here, you will get the same value. Let's check. Okay, substituting y equals to 3 to get t. Okay, so if I plug in y as 3, t square e to the power 3, e to the power t plus 3. Okay. Okay, 3 and 3 will cancel out. So you have t square e to the power t. Okay, so you've got two functions here. So t square equals to 0. So that is giving you t 0, and e to the power t equals to 0. So t equals to ln 0, which is undefined. Okay, so you're getting the same value of t from both. Okay, so you have to substitute the value of t, which is 0, into dy by dx. Substituting t equals to 0 in dy by dx. Okay, so this was the result of dy by dx. I have to plug in. T as 0 in this. Dy by dx equals to 0 into 0 plus 2 upon 3e. 2 into 0 is 0. So 2 upon 3. This is the answer. This is what they said. Show that the tangent to the curve is parallel to the x-axis. Okay, sorry. 0 multiplied by anything gives you a 0. So 0 into 2 is 0. 0 upon 3, that means 0. So proved that dy by dx, you can write that since dy by dx equals to 0, tangent as parallel to the x-axis. Okay. Last part of the question. It says find the exact coordinates of the other point on the curve at which the tangent is parallel to the x-axis. Okay, tangent is parallel to the x-axis, meaning dy by dx equals to 0. So let me make dy by dx equals to 0 here. Okay, 0 for the third part. Substituting dy by dx. Substituting dy by dx to get the other point. 0 equals to t into t plus 2 upon 3e to t. Cross multiplying t into t plus 2 equals to 0. So t equals to 0 and t equals to negative 2. Okay, if you plug in t equals to negative 2 into x and y, we will get the value of the other coordinates. Substituting t equals to 2 to get x and y. Okay, x equals to e to the power 3 into negative 2. So e to the power negative c. Y equals to, if I plug in t as negative 2 square e to the power negative 2 plus 3. Okay, so since we have to give the exact coordinate, let's simplify. 4 upon e square plus 3. So the coordinates x comma y is going to be 1 upon e6 upon comma 4e square plus 3. This is the answer to question number 3. Okay, let's move on to question number 4. It says find the gradient of each of the following curves at the point where x equals to 0. Okay, so you have to differentiate this dy in the first part. I'm copying the equation of the curve, which is y equals to 3 sine x plus tan of 2x. Okay, dy by dx, we know the differentiation of sine is cos, so it will be 3 cos x plus differentiation of tan we know is sec square, so it will be sec square 2x times 2, because once you know tan of x is sec square, so tan of 2x will be sec square 2x, and then you have to differentiate it and multiply it here. Okay, you have to substitute x equals to 0, 3 into cos of 0, which is 1 actually, 3 into cos of 0 plus 2 sine squared 2 into 0. 2 into 0 is a 0. Cos of 0 we know is 1. So 3 plus 2 sine of 0 is 0 square. So the answer is going to be 3. Second part. Y equals to 6 upon 1 plus e to the power 2x. You're supposed to differentiate it and plug in x equals to 0 now. Now I'm going to shift this whole thing. I can shift this whole thing up in the numerator and make a power of -1 here, or I can deal with it with u upon v formula. Okay, so writing u equals to 6, u dash is going to be 0, v equals to 1 plus e to the power 2x, so v dash is going to be e to the power 2x into 2. Okay, so dy by dx is going to be v, which is 1 plus e 2x, u dash, which is a 0, minus u v dash is going to be 2e 2x upon 1 plus e to the power 2x square, v square. Okay, so obviously anything multiplied by 0 is 0, so you just have to solve this part now. Minus 12 e 2x upon 1 plus e 2x whole square. Okay, now we're going to substitute x equals to 0 in this. Substituting x equals to 0, it will become minus 12 e to the power 0, which is a 1, upon 1 plus e to the power 0 the whole square. This will become minus 12 upon 1 plus anything to the power 0 is 1 only. 1 plus 1 is 2. 2 square is 4. So the answer is minus 3. Okay, moving on to question number 5 then. Okay, I made a mistake here. This was sec square. I wrote, by mistake, I wrote sec square x. So let me just fix this. Okay, it is sec square 2x. So sec square of 2 into 0. Okay, cos of 0 is a 1. So sec of 0 is also going to be the reciprocal of, if cos of 0 is 1, sec of 0 will be the reciprocal of 1. So which is 1 only. So it's going to be 1 square, which is 3 plus 2, which is actually 5. Okay. Question number 5. The equation of a curve, this is the implicit differentiation. Equation of a curve is this. The equation of the curve is given in terms of x and y. Find the equation of the tangent to the curve at the point this, giving your answer in the form. Okay, fine. First of all, we're going to do implicit differentiation here. So let me write down the equation. 2x squared plus 3xy plus y squared equals to 3. Okay, so I'm starting with the differentiation process. So 4x plus this, I have to deal with the product loss. So first as it is, I'm taking the first function as 3x and the second one as y. First as it is, differentiate the second one. Whenever I'm going to differentiate y, I'm going to write dy by dx with it. Plus second as it is, differentiate the first one. Plus differentiation of y square will be 2y, and since I'm differentiating it, I will write dy by dx with it equals to 0. Differentiation of 3 is 0. Now let's simplify this. 4x plus 3x dy by dx plus 3y plus 2y dy by dx equals to 0. All the terms with dy by dx on this side and the rest of the terms I'm going to shift there. So I'm writing 3x dy by dx, or I can actually take out common with, along with this step. So I can write dy by dx 3x plus 2y equals to negative 4x negative 3y. dy by dx is equals to negative 4x negative 3y divided by 3x plus 2y. This is I've got dy by dx right now. Now I have to find out the equation of the tangent to the curve at 2 comma negative 1. Substituting x equals to 2 and y equals to negative 1 to get the gradient of the tangent. Okay. So dy by dx equals to minus 4 into 2 minus 3 into upon 3 into 2 plus 2 into minus 1. Okay, minus 8 plus 3 upon 6 minus 2. Minus 8 plus 3 is minus 5, 6 minus 2 is a 4. Okay, now we have to find out the equation of the tangent to the curve at this point. Okay, substituting gradient equals to negative 5 upon 4 and the point which is 2 comma negative 1 to get the equation of the tangent. Okay, y minus y1 equals to m x minus x1. Okay, so y minus y1 equals to gradient x minus x1, cross multiplying 4y plus 1, 4 equals to minus 5x plus 10, 5x plus 4y equals to 10 minus 4, which is a 6. This is the equation of the tangent which I was supposed to find out in the first part. Achha, they said write it in this form. Okay, so if you have to write it in this form, bring 6 also onto this side. Five x plus 4y minus 6 equals to 0 is the equation of the tangent. Now that they are saying that show that the curve has no stationary point. If you make dy by dx equals to 0, let's see what do we get. Now, for at stationary point, we know dy by dx equals to 0. Okay, just copying this thing. Okay, third, this is the second part of. We have to make dy by dx equals to 0. Minus 4x minus 3y equals to 0. Okay, now if I substitute okay. X equals to 3 upon minus 4y. Okay. Okay. Now, if I take the equation of the curve, which is here, Substituting x into this equation, and let's see whether we get some value for y or no. Okay, so let's do this. Minus 3 upon 4y Okay, let's solve this. 2 into 9 upon 16 y square minus 9 upon 4y square plus y square equals to 3. Okay, let's check out the LCM. LCM of 8 and 4 is 8. 9y square minus 18y square plus y square equals to 3. Okay, so I'm getting a minus 8y square equals to 24. Y square equals to 24 upon negative 8. Y square equals to negative 3. We don't have a square root of a negative number, so no turning point. No stationary point. Okay. Moving on to question number 6. The equation of a curve is y cube plus 4xy equals to 16. Show that dy by dx equals to this. Okay, let's prove this first. It's y cube plus 4xy equals to 16. Y cube plus 4xy equals to 16. Okay, if I have to find out the differential of this, I write 3y squared dy by dx. I'm doing implicit differentiation plus first as it is. I'm taking it as two functions. First as it is, differentiate the second one, plus second as it is, differentiate the first one, equals to 0. Okay, dy by dx, I'm taking out 3y square plus 4x is common, and I'm shifting 4y onto that side. So dy by dx is going to be minus 4y upon 3y square plus 4x. Okay, this is the answer of the first part. Find the show that the curve has no stationary point. So you have to make dy by dx equals to 0. Make dy by dx equals to 0. 0 equals to negative 4y upon 3y square plus 4x. 0 equals to negative 4y, so y equals to 0. Okay, if I substitute y equals to 0 in this, okay, 0 cube plus, okay, just substituting y equals to 0 in the equation of the curve. 0 cube plus 4x into 0 equals to 16. Now this, anything multiplied by 0 is a 0. It's cancelling out. You're not left with any x. So the curve has no stationary point. Okay. Find the coordinates of the point on the curve, the last part. Find the coordinates of the point on the curve where the tangent is parallel to the y-axis. Tangent is parallel to the y-axis. That means whenever the tangent is parallel to the y-axis, that means the gradient is undefined. That means rise upon run. Run is actually 0. Okay, so whatever is the denominator is actually 0. So since we already have dy by dx with as if you make the denominator equals to 0. Okay. Okay, I'm copying dy by dx from up here, minus 4y minus 4y upon 3y square plus 4x equals to, we know whatever is the rise, run is 0. So we have to make 3y square plus 4x equals to 0. So I can make x a subject from here. 4x equals to minus 3y square and x equals to minus 3 upon 4y square. If I plug in x as negative 3 upon 4y square in the main equation of the curve, I will get the value of the coordinates. Okay, so I'm just copying the equation of the curve here. I'm getting the equation of the curve here. Which is this. I'm going to substitute x as negative 3 upon 4y square. Y cube plus y cube minus 3y cube equals to 16. If I take out y cube is common, or I can just simply solve it. Minus 2y cube equals to 16, y cube equals to negative 8 and y equals to negative 2. And obviously if y is a negative 2, x was minus 3 upon 4 y square. So it's going to be minus 3 upon 4 negative 2 square. X equals to negative 3. So the coordinates are negative 3 comma negative 2 for this part, question number 6. The third part, negative 3 comma negative 2. Okay, now we move on to question number 7. The equation of a curve is this. Find the equation of the tangent to the curve at this, giving the answer in this form. Okay, fine. So firstly we'll find out dy by dx of this. 6 sin x minus 2 cos 2x. dy by dx is going to be 6 cos x plus 2 sin 2x multiplied by 2. Okay, why? Because the differentiation of sin x is cos x, so 6 cos x minus differentiation of cos x is negative sign, so negative becomes positive. Differentiation of cos of 2x is sin of 2x multiplied by 2, so 2 was already here, so that's why I wrote 4 sin 2x here. So once I've differentiated it, I'm going to plug in the value of x in this. Substituting x equals to 1 upon 6 pi. So dy by dx is going to be 6 cos pi by 6 plus 4 sin 2 into pi by 6. Okay. 6 pi by 6 is 30. Cos of 30 is under root 3 upon 2 plus 4 sin of pi by 3. Pi by 3 is 60. Sin of pi by 3 is also root 3 upon 2. Okay, so I can write root 3 upon 2 here. So if I simplify this, it has become 3 root 3 plus 2 root 3, which is actually 5 root 3. Okay. Okay, now let's find out the equation of the tangent to the curve using m equals to 5 root 3 and pi by 6 comma 2. We are finding out the equation of the tangent. Y minus y1 equals to gradient x minus x1. Y minus 2 equals to 5 root 3 x plus 5 root 3 upon 6 pi they have told us that giving the answer in the form is where the values of m and c are correctly because so m is 5 root 3. I can take the value with the calculator. 5 root 3 is 8.66. Okay, so I can take this as 8.66. (8.66x minus 8.66 multiplied by pi by 6), which is 4.53. Okay, so y equals to 8.66 x minus 4.53 plus 2. Y equals to 8.66 x minus. This is the answer to question number 7. Okay, we'll come to the end of this video. Thanks a lot for watching it.